Now number 5 is something that's a little more sophisticated, but it's all skills that you already have. Basically with number 5, we don't have any of our equations that is giving us an x equals or a y equals statement. Our job is to create one by isolating the x or the y alone. I'm going to choose to isolate this x by itself because I see that it's going to be pretty easy to get it alone. Watch this. I am going to add 4y to both sides. Oops. Sorry, that y looks like an x. I'll try to fix it. And if I do that, I end up with a statement that looks like x equals 4y plus 12. Now I've got a statement that tells me exactly what x is equal to, so that when I go to the other equation, I can take the x out and I can replace it with 4y plus 12. All it takes is getting one of your variables alone so that you can do that. Which means now I can take this first equation, the one I haven't used, and write 3x minus 5y, I'm just recopying now, equals 15. I know, based on my information down here in the equation that I created when I move things around, that I'm going to replace the x with this stuff. So I'm going to find my x in my equation, put parentheses around it, and I'm going to rewrite one more time, but I'm going to take the letter x out, and I'm going to replace it with this stuff that's equal to x, 4y plus 12. Now I've got to continue up here with, minus 5y equals 15. I haven't done that yet. Minus 5y equals 15. And I do exactly what I did last time. I take my positive 3 and I begin with the distributive property. I am going to multiply 3 times 4y to get 12y. Then I'm going to multiply 3 times 12 to get positive 36. Remember, positives turn into pluses, just like negatives turn into minuses. Now I have to do minus 5y equals 15. I'm going to combine my y's into one group of y's, because right now I have two groups. I'm going to combine like terms. 12y and negative 5y is 7y. I'm going to bring down plus 36 equals 15. Now I've got to extend my blue line here. I'm going to subtract 36 from both sides. That cancels out my 36. 7y equals negative 21. Remember, if you didn't know that, please use a calculator. Don't get it wrong for something silly. And I'm going to divide by 7. Y is equal to negative 3. Alright, so I've got part of my final answer. I've actually got my second number, y is negative 3. And now I have to go back and I have to calculate what x is. It's going to be pretty easy because during my work I found a statement that told me exactly how to find x. I'm going to use that. Now that I know my y, I'm going to be able to rewrite this and replace it with negative 3, because I know now that y is equal to negative 3. So I've got x equals 4 times negative 3 plus 12 negative 12 plus positive 12 equals 0. So x is equal to 0. There's my partial answer of x, my partial answer of y, and my final answer. Those two lines cross at 0, comma, negative 3. The last two problems we're going to do are elimination problems. In order to eliminate, what we are looking for are opposites. We're looking for the same number of x's or y's, but with opposite signs. Sometimes we have to create that. So when I look at number 7, for example, I notice that I'm going to go ahead and fill in, I have 1x minus 1y, 1x minus 1y equals negative 10. Then I've got 1x minus 6y equals negative 25. In elimination, we're going to be adding vertically, and my goal is to either cancel out my x's or cancel out my y's with opposites. It looks like the x's are going to be quite easy because they each already have 1. I just need to make one of those 1x's negative. I'm going to do that by multiplying the whole equation times negative 1. When I do that, I have to multiply each piece of the equation, all three parts, by negative 1. Which means if I move everything over this way, my first equation I chose to leave the same. I've got 1x minus 1y equals negative 10. My second equation, I'm going to have to do this multiplication. I'm going to have to say negative 1 times 1x is negative 1x. Negative 1 times negative 6y, that minus makes that negative, equals positive 6y. And negative 1 times negative 25 gives me positive 25. Now I get to make my total line. I'm going to add each column. So when I add that 1x and that negative 1x that I created, my x's cancel out and disappear. Negative 1y and positive 6y gives me 5y. And negative 10 plus 25 gives me 15. Divide each side by 5 to isolate my y, and now I know that y is equal to 3. I'm going to need to use that 3 because I'm going to have to replace one of my y's. I'm either going to choose this equation or this equation. I'm going to replace the y with the value of 3. I'm going to choose the first one. I often just go back to the first one. I am going to put parentheses around my y because the y value is what I know. 1x minus 1 times 3 equals negative 10. When I multiply negative 1 times 3, I get negative 3. So I've got 1x minus 3 equals negative 10. I'm going to start to run out of room, so I think I'm going to rewrite this up here. 1x minus 3 equals negative 10. This is a two-step equation I can solve just like I have been doing since pre-algebra. Add 3. 1x is equal to negative 7. You could divide by 1 if you wanted to, but you would end up with x equals negative 7. So my final answer, negative 7, comma 3. Now each elimination problem is a little bit different. In this particular case, as I'm looking at my numbers, every single number in front of my x's and y's is positive, which means I'm definitely going to have to multiply by a negative. I need some kind of opposite so my x's or y's cancel out. Now I've got to decide what is the easiest way to get the same number, because I notice, unlike the last problem, there are 3 x's up here. I'm going to fill in my invisible 1. There's only 1 x down below. I have 6 y's here, but only 2 y's here. So I've got to figure something out. I think the easiest way to get opposites is to multiply this equation times negative 3. My goal in doing this is that I would get a 3x, which is already in the top equation, and then I would have a negative 3x, which would cancel out. If I multiply by negative 3, remember I have to multiply each piece of this equation by negative 3. So the first equation won't change. 3x plus 6y equals 27. And my bottom equation, I do negative 3 times 1x for negative 3x. I do negative 3 times 2y for negative 6y. And I do negative 3 times 11 for equals negative 33. Now I get to add. My goal originally was to get 3x and negative 3x so my x's would cancel, and it looks like I've been successful. 3x and negative 3x cancel. But look what's happened here. I've also, without trying to, canceled out my y's. Positive 6y and negative 6y cancel one another out. What do I even have left on this side of the equal sign? Well, I've got a 0. And then I've got this math to do. I've got 27 and negative 33, which gives me negative 6. Now, there's a couple different possibilities for answers that do not have any more x's or y's left. In this case, I have to look carefully at my numbers. Is it true that 0 is equal to negative 6? Nope, it's not true. Therefore, my final answer would be no solution. The trick is remembering when it's no solution and when your answer is infinite solutions. So let me give you a couple examples that you can write down. If your problem is something like 0 equals 3, that is a problem that is an answer of no solution. 0 is not equal to 3. You can put that slash in there, which means there is no solution. You've got 2 parallel lines on the graph that will never cross. On the other hand, If I get something that looks more like 0 equals 0, or 3 equals 3, those are true statements. The answer to those problems would be infinite solutions. Or, in other words, you actually have two of the same line graphed one on top of each other. They share an infinite number of points in common. It is okay if all of your variables disappear. Just remember, take a look at that final answer. If it's not true, you write no solution. If it's true, like 0 equals 0 or 3 equals 3, you write infinite solutions.